Dear friends, I myself, Dr. Bharat Parab, discussing exercise on the topic factor theorem in polynomials or factorization part 1. Okay, so now the exercise. First one, determine which of the following polynomials has x plus 1 as a factor. Okay, first one, x cube plus x square plus x plus 1. Now answer, for x plus 1 to be a factor of any polynomial, minus 1 has to be the zero or root of the polynomial. This means that you have to substitute x by minus 1 and see the value of polynomial and it should be 0. Okay, so if we copy this down like this and substitute minus 1 for x, so minus 1 cube plus minus 1 square plus minus 1 plus 1. So this comes out to be minus 1, then plus 1, minus 1 and plus 1. It is 0. So therefore x plus 1 is a factor of px. This is px. This is px. Okay, very simple. Now we have to check for another polynomial x raised to 4 plus x cube plus x square plus x plus 1. Same thing, we have to substitute for x plus 1, we have to substitute minus 1. 0 of this polynomial, 0 this polynomial is minus 1. Okay, we know the theory of 0 of polynomial. Okay, so we will substitute 0 value of this polynomial in this. Okay, so minus 1. So px equal to x raised to 4 plus x cube plus x square plus x plus 1. So this comes out to be minus 1 raised to 4 plus minus 1 cube plus minus 1 square plus minus 1 plus 1. And this comes out to be, if you solve, 1 minus 1, 1 minus 1, 1. So it's 1, not 0. So x plus 1 is not a factor of px, where px is this. Okay, very simple. Exercise continued. Again, the third polynomial, we have to check whether x plus 1 is a factor of this. X raised to 4 plus 3x cube plus 3x square plus x plus 1. Okay, we know what to do. We have to, if x plus 1, so we read it again, for x plus 1 to be a factor of any polynomial, minus 1 has to be the 0 or root of polynomial this, because that is the 0 of this. That means substitute x by minus 1 and check the 0 of the polynomial. So we are taking it px equal to, you can take qx or rx, anything at this, at p. Okay, no need to take p every time. So x raised to 4 plus 3x cube plus 3x square plus x plus 1. So substitute minus 1 raised to 4 plus 3 into minus 1 cube plus 3 into minus 1 square plus minus 1 plus 1. So it comes out to be 1 minus 3 plus 3 minus 1 plus 1. So it is 1, not equal to 0. So x plus 1 is not a factor of px, where px is denoted for this. Okay. Fourth one, x cube minus x square minus into bracket 2 plus root 2 x. Okay, the bracket completed x plus root 2. Okay, so to substitute x by minus 1, I'm doing it, minus 1 cube minus minus 1 square minus 2 plus root 2 into minus 1 plus root 2. So if you try to solve this, arrive at this answer, 2 into 1 plus root 2 into bracket, which is not equal to 0. So x plus 1 is not a factor of px, where px stands for this. Okay. Second one, use factor theorem to determine whether gx is a factor of px in each of the following cases. First one, px is equal to 2x cube plus x square minus 2x minus 1, and gx is x plus 1. Okay, answer px is this. I'm not reading it again. Okay, and we have to check whether x plus 1 or gx is factor of this. So we have to use factor theorem. So I am factorizing it. I'm taking x square common. So what remains in bracket is 2x plus 1. And if you take minus 1 common here is 2x plus 1. Now take a 2x plus 1 common from this and this. So we are left with x square minus 1 into this bracket. And if you again factorize this, you get 2x plus 1 as it is. And this is x plus 1 and x minus 1. So x plus 1 is factor of this. So gx is equal to x plus 1 is factor of px. Okay, or this is not given in this, but we can check it like this also, that for x plus 1 to be factor of any polynomial, minus 1 has to be 0 or root of the polynomial. This means if you substitute x by minus 1 and see the value of polynomial, it should be 0. So I'm substituting it. See, in place of x, I'm writing it like this, and 2 into minus 1 cube plus minus 1 square, very simple, minus 2 into minus 1, minus 1. If you check this, this comes out to be minus 2 plus 1 plus 2 minus 1 is 0. So as value is 0, so gx, which is equal to x plus 1, is factor of px. Okay, very, very simple. Second exercise continued. We have to see gx is factor of px. Here px and gx may change. Second one, px is equal to x cube plus 3x square plus 3x plus 1, and gx is x plus 2. Okay, so answer, this is px. I am writing this px in a different manner. Keeping this, we have to see that x plus 2 is a factor. So remember, you have to keep this in mind. Okay, so I'm writing it x cube plus, I have to write 2x square, so that I will get x plus 2 common in this. Okay, and then x square remains. This total becomes 3x square. Now see, I have to write this 3x as 2x plus x and plus 1. Okay, so see, now I am taking x square common in this. So what is remaining in the bracket is x plus 2 plus x common in this. So x plus 2, and this is x plus 1. Okay, now I am taking x plus 2 common in these two terms. So x plus 2, what remains in the bracket is x square plus x. Okay, in this, and this is carried as it is, x plus 1. Now I am taking x common in this. So x plus 2 into x plus 1 plus x plus 1. Okay, see, very interesting. Now x plus 1 is common, is to be taken common from this. So if you take this x plus 1 common in this, and this is a whole term. Okay, so I am taking this. So this coming here, what remains in the bracket, in big bracket, is x into x plus 2, got it, and plus 1. Okay, this shows that gx, x plus 2, is not a factor of px. Okay, had this been plus 2, then it would have been, but it's not a case. Okay, this is finding gx is a factor of px by factor theorem. Okay, or by another method which is not given by the exercise, but we are just trying to check. Okay, so for x plus 2 to be factor of polynomial, that polynomial, okay, minus 2, you know, this minus 2 has to be 0 or root of the polynomial. This means you have to substitute x by minus 2. We have seen this, okay, in many examples. So I'm substituting minus 2. Remember, minus 2 sign is very, very important. Okay, so px equal to x cube plus, in all this I'm just substituting minus 2 cube plus 3 into minus 2 square plus 3 into minus 2 plus 1. Now solve this. This is minus 8 plus 3 into 4 minus 3 into 2 plus 1. So minus 8 plus 12 minus 6 plus 1. This comes out to be minus 1 but not 0. Okay, as it is value is not 0, that means gx, which is x plus 2, is not factor of px. Okay, very simple. So third one, in this we have to check whether gx is factor of px by factor theorem. Okay, so the third one, px is this and gx is x minus 3. I'm not reading this. Okay, directly going for the answer. So answer px equal to x cube minus 4x square plus x plus 6. Keeping this in mind, we have to adjust the term or write the terms in such a way that you should get x minus 3 common somewhere. So see here. So x cube, this 4x square can be written as minus 2x minus 2x, which is not of much use here because we want x minus 3. So I am writing these terms like this. Okay. So x cube minus 3x square minus x square plus x plus 6. Okay. So taking x square common, so x minus 3 minus, I'm taking minus and common. So inside this, get x square. This sign will change. It's minus x, and this is also going to change. It's minus 6. Okay. Now x square into x minus 3. Okay. Minus. See, this is minus. This is not. This is one of the factor. Okay. You had this been multiplied to this, then it would have been easy. Okay. But this is minus sign. We have to check. So we have to find the factors of this. X square minus 3x plus 2x minus 6. Okay. Splitting middle term. Then we have to copy this like this. Then x into x minus 3, taking x common in this. Okay. And taking 2 common in this should be x minus 3. Now taking x minus 3 common in this bracket, you get x square into x minus 3. So minus x minus 3 into the big bracket is x plus 2. Now from the whole thing we are taking x minus 3 common, and into this bracket goes x square minus what is remaining in this. Okay, minus into bracket x plus 2. Okay, but this bracket, whatever it may be, is multiplied by x minus 3. So x minus 3 is a factor of px. So it's given here. See here. Okay. So don't think it is complicated. If you have enough practice, then this is actually very, very easy. Okay. Try it. I'm just giving this solution, though this is not to be given in exam, or this is not given in this exercise, but just for curiosity. Okay. So for x minus 3 to be factor of polynomial, given polynomial, 3 plus 3 has to be 0 or root of the polynomial. So we have to substitute x by 3. I am substituting it. Px is all this. Then substituting 3 cube minus 4 into 3 square plus 3 for only x plus 6. So this is 27 minus 4 into 9 is 36. Coming it directly here. This is 27 plus 9 is 36 minus 36 is 0. Okay. So we are getting this as x minus 3 is factor of px. Okay. By this method also. Okay. So try some problems. Now third one. This is similar one on similar basis, but a little different way. Find the value of k if x minus 1 is a factor of px in each of the following cases. Here, first one, see, we have to find the value of k. K will be somewhere here, and if this is a factor, then we will see px is equal to x square plus x plus k. Okay. Now, answer, for x minus 1 to be a factor of any polynomial, 1 has to be 0 or root of the polynomial. You know this. Okay, we have seen this. That means you substitute x by 1 and the polynomial value is 0, then you get it. Okay, we know it is a factor, so it has to be 0. So I'm just substituting it. This is copying it like this, and 1 square plus 1 plus k is equal to 0. Okay, if this has to be factor, then this has to be 0. So 1 plus 1 plus k is 0. So 2 plus k is 0. So k is minus 2. Got it? Very, very simple. Second one, px equal to 2x square plus kx plus root 2. Now answer, for x minus 1 to be factor of any polynomial, 1 has to be 0 or root of the polynomial. That means you substitute x by 1 and polynomial value should be 0. Okay, so I'm doing it. Px is this, or this copied down. So x has to be replaced by 1. So 2 into 1 square plus k into 1 plus root 2. So if you solve this, 2 plus k plus root 2 equal to 0. So k has to be, it will all this come on this side with change the sign. So minus into bracket 2 plus root 2. Okay, or k is supposed to be minus 2 minus root 2 if bracket is omitted. Okay, very simple. So title continued. Find the value of x if x minus 1 is factor of px. Okay. Third one, px is kx square minus root 2x plus 1. We know answer for x minus 1 to be factor of the polynomial. 1 has to be 0 or root of the polynomial. That means x should be replaced by 1 and polynomial value should be 0. So I am doing it. Px is equal to all this. So P1 is equal to k into 1 square minus root 2 into 1 plus 1. So you get k here minus root 2 plus 1. So this will go on this side with change sign. So k is equal to root 2 minus 1. Okay. So this is again very simple. Now fourth one, px is equal to kx square minus 3x plus k. Okay. So we have to replace x by 1. You have seen this. Okay, so I'm coming directly here. Px equal to kx square minus 3x plus k. So k into 1 square minus 3 into 1 plus k is equal to 0. So this k and this k is 2k minus 3 0. So k is equal to 3 upon 2. This 3 will come here and 2 goes down. So k is plus 3 upon 2. Okay, again very simple problem. Fourth one, factorize. First one in this 12x square minus 7x plus 1. Answer, we have to split the middle term as its addition should be same as the middle term. Okay, we have seen this even before. And multiplication should equal the multiplication of coefficient of first term and last term. Okay, multiplication of these two terms. You will see this as you go ahead in the problem or in this topic. You will come to know the exact meaning of this. Okay, it's given here also. So let us split the above polynomial as this is a polynomial. So I am splitting this minus 7x as say 12x square minus 4x minus 3x plus 1. So we have to split this in such a way that I am, see it is given here, where minus 4x minus 3x is minus 7x. Okay, and minus 4 into minus 3 is 12, which is 12 into 1. Okay, is equal to 12. This is the meaning of this. Okay, so this is very important. I can split this minus 7x as minus 5x and minus 2x. This is of no use at present. Okay. So we get, say I am taking 4x common in this. So what remains in bracket is 3x minus 1 and minus 1 common in this. So it is 3x minus 1. Now 3x minus 1 common in the whole thing. And in the bracket we get 4x minus 1. Okay. So these are the factors of this. Okay, very simple. Second one, 2x square plus 7x plus 3. So let us split the above polynomial as this is a polynomial. I am splitting it as 2x square plus 6x plus 1x plus 3. Okay. So where plus 6x plus 1x is 7x and 6 into 1 is 6. That is this 2 into 3. Okay. So if you look at this, if you take 2x common from this, you are left with x plus 3, and if you take 1 common in this, so you are left with x plus 3. Okay, now x plus 3 common in the whole thing, and in bracket you are left with 2x plus 1. Very simple. Okay, these are the factors of this. Okay, so factorization continues. Okay, I advise you to solve both these problems yourself and then look for the solution. Okay, so third one, 6x square plus 5x minus 6. Okay, so you know the what is written here. So I'm directly coming here. So 6x square plus 5x minus 6 can be written as 6x square plus 9x minus 4x minus 6. Okay, why we have to split it like this, we'll come to know. You have to have enough practice for this. Okay, now, because we want a minus 36, so you should have one minus sign in this. Okay, so see it is given here where plus 9x minus 4x is plus 5x. Okay, and plus 9 into minus 4 is minus 36, that is this 6 into minus 6. Okay, so we get, if you come here, we get, take 3x common, then what is left in the bracket is 2x plus 3, minus 2 common, then 2x plus 3, and again 2x plus 3 common in this, you get into the bracket uh, this 2x, besides this 2x plus 3 you are getting 3x minus 2. Okay, so these are the factors. And fourth one, 3x square minus x minus 4. Okay, now let us split the polynomial. Okay, uh, 3x square minus x minus 4 is written as 3x square minus 4x plus 3x. Okay, minus 4. Okay, where minus 4x plus 3x is minus 1x, and minus 4 into 3 is minus 12, which is 3 into minus 4. Okay, so if you take x common, you get 3x minus 4, and in this, if you take 1 common, then 3x minus 4, and 3x minus 4 to be taken common in both these, we are left with x plus 1. So these are the factors. It's very, very simple. Okay, try some problems. Okay, this is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of exercise, we have seen factor theorem in polynomials or factorization. Now this is exercise part 1. Okay, so if you have any difficulty, let me know through comment section and I shall solve it. Okay, there is another part also, part 2. Okay, so please like, share and subscribe, and let everybody of you get benefit of this. Okay, thanking you. Good luck.